This short video is about how to use calculus to derive from a total cost curve, both the average cost curve and the marginal cost curve, to find the point of lowest average cost. The basic concept that we're working with here is a relationship between the different cost curves to find out the point in business that business would often want to know, which is the lowest market price that they can operate at in a market. Basically, the concept we're going to be working with is taking a total cost curve, and from this total cost curve, finding both the marginal cost curve and the average cost curve, how to set them equal to each other to find the key idea, which is where marginal cost equals average cost, that is the point of lowest average cost. So, in order to do this, I have my total cost curve laid out here as an equation. And from this total cost curve, I'm going to derive two different curves, my marginal cost curve and my average cost curve. First, I will use some calculus to do my marginal cost curve. My marginal cost, which mathematically would be how a change in the quantity that I produce will change my total cost. I will use the power rule to get the first derivative, which would be my marginal cost curve. That, quite simply, would be 700 minus 60q plus 6q squared. So that's the first curve that I need to find. That is my marginal cost curve. The second curve I need to find is my average cost curve. My average cost curve is quite simply my total cost divided by my quantity. And for this, I'm going to use basic algebra to simply factor a q out of each piece of the equation, which will give me 700 minus 30q plus 2q squared. So the basic idea is all I need to know is my total cost curve, and from that I can use calculus to derive my marginal cost curve and basic algebra to derive my average cost curve. The next part of solving this is quite simply just setting the two equations equally to each other. So in this case, I will have 700 minus 60q plus 6q squared equal to 700 minus 30q plus 2q squared. And at this point, it's just a little bit of algebra to clear things up and to simplify down my equation. The 700s basically cancel out. If I bring everything else over to one side, what I will have is 4q squared minus 30q equals 0. And what I can do with this is I can factor out my q's, which will give me q bracket 4q minus 30 equals 0. Now this gives me an opportunity to think that I have two q's where this will happen, but one of them really doesn't exist, because I should know that when I'm producing nothing, my marginal cost and my average cost are going to be the same. It's the internal factor here that will tell me the number that I want to know. So I need to set this internal piece equal to 0 to find out the quantity that I want. So if I have 4q minus 30 equals 0, that will result in me finding that q equals 30 over 4, or 7 1/2. So at 7.5 units of production, my marginal cost will be equal to my average cost, which is my point of lowest average cost. So I know how many units to produce. But companies want to know more than just how many units to produce. What they often want to find out is what is the lowest minimum price that they can operate in with the market. Now, in order to do that, I need to take my answer to my quantity, and I need to plug that back into my average cost curve, because this will tell me what my average cost will be at 7.5. So what I do is I simply take my average cost curve, and everywhere I have a Q, I plug in 7.5. 700 minus 30 times 7.5 plus 2 times 7.5 squared. If I plug and chug my way through this, what I'll find is that my average cost will be 700 minus 225 plus 112.5. Doing all of this will give me an average cost of 587.5. What this is basically telling me is that as a company, the lowest price I can go in a market is $578.50. The general concept is that in a market, I want my price to be greater than or equal to my average cost, which in this case is $587.50. At any price higher than this company will be able to profit. At any price below this company should leave the market. Thank you.